Hello and welcome back. This again continuing the series of the final three. So I'm working my way through the final three questions of all the exam papers from June 2017. If you look at the other videos available on my channel, you'll see I've been doing these all the way through for the last couple of weeks. This particular paper today is June 2018 paper 2. If you're new to the channel, it'd be really appreciated if you could leave a like and subscribe. I'll keep adding videos in the near future, so please do check back. And if you want to make any comments, there is a comment section below. So, as I mentioned, this is June 2018 paper 2. This particular question is number 19. This is a little bit of a stretchy question. It talks about using a sphere. They're giving you some helpful help here. So 4/3 pi r cubed being the volume and 4 pi r squared being the surface area. Those are quite useful formulas. We're going to need them today. And it's talking about the volume of this, shape S, which represents 1/4 of a solid sphere, so 1/4. And it's asking you to find the surface area. So the strategy for this is relatively simple. You use these facts to work back and find the radius, and then you use the radius to find the surface area. So that's the strategy we're going to use. The key thing here is to make sure you take a note of the question, because it does tell you everything you need to know, but the very simple mistakes is to miss bits out of the question or miss details out of the question. So the fact that this represents 1/4 is quite a critical thing. So in this case, we're going to start with the volume and get an expression for the volume or an equation for the volume. We're told the volume of a whole sphere is 4/3 pi r cubed, but yet we only have a quarter here, a quarter of a sphere. So this particular volume of this particular sphere will be 1/3 pi r cubed because it's a quarter of that. So a quarter of this is 1/3 pi r cubed. 1/3 pi r cubed therefore is 576 pi. We can cancel the pi's on both sides. We can multiply both sides by 3 to get 1728. And then we're going to cube root the 1728. And again, because this is a calculator paper, we can use our calculators for that. Now, in case you don't know where your cube root button is, it's just here, so it's a little bit blurry. Try and get it a bit better for you. There it is. So cube root button there's a square root button, there's the cube root button. So I'm going to press shift and there, so you can see the cube root icon appears, and I'm going to do 576 here. Sorry, take it back, 1728 here, which is the value that I had in the question. So I put that in there, and then equals, and you'll get 12. Hooray! Nice, easy. So 12 centimeters. That's the radius. Now we need to work out the surface area. The surface area you do need to think about quite a lot. Now this is telling us the surface area of a sphere, so a whole sphere is 4 pi r squared, but remember I've only got a quarter of a sphere here. Now the curved surface area is this bit here. So that here is going to be a quarter of this. So a quarter of 4 pi r squared, in other words just pi r squared. So the curved surface area, this bit here, is pi r squared, but you've got to take into account this bit, which is half a circle, and this bit, which is half a circle. So these two things combined will be a whole circle, another pi r squared. So the surface area of my sphere S will be this bit, which is a quarter of this, so pi r squared, and then this bit, which is another circle, another pi r squared. So the surface area is 2 pi r squared, that's the quarter of the pi r squared plus the other bit circle. And we know that r is 12, so I'm going to put in r is 12 here, put the pi at the end, so we're going to get 288 pi, and then all you've got to have to do is work that out and write it down to 3 significant figures, which is what the question asks you for. You'll have to press the SD button, which again, a reminder is just there, and you'll get this, and this, the 3 significant figures, is 905, so 905. So we're going to write that down here, and that will hopefully guarantee us our 5 marks. Moving on, we're going to look at question number 20. This is an interesting question. These are becoming a little bit more common in GCSE, questions asking you where people are going wrong with their calculation. It's quite unusual, this particular question, because it's so far through the exam. It's right towards the end. So these questions are a bit pushy and will require you to do a little bit more thinking. So it's talking about rationalising a denominator here. So 14 over 2 plus root 3. And you can see that what they're doing is they're multiplying by 2 minus root 3 here on top and bottom. There's nothing wrong with this so far. You've got to search through and find where the mistake is made. You have to be very, very cautious and just look quite carefully where they're making a mistake. So let's have a look at the top part first of all. Does he multiply 14 by 2? Yes, he does. Does he multiply 14 by root 3? Yes, he does. And the sign is correct. On the bottom, 2 times 2 is 4, so that's correct. 2 times minus root 3 and 2 plus 2 times root 3 does equate out to this. But then this is where the mistake is made. Root 3 times minus root 3 is minus 3 and not plus 3. So this is where the mistake is getting made. So you just need to show or write a little bit of explanation about that, and then you'll be getting the 1 mark that this question is worth. Down the bottom end, it's talking about, again, same thing, rationalising denominator, wherever they made the mistake. So again, nothing wrong here. Root 12 and root 12 is what you would multiply. But just be aware that root 12, as you know, or should know, is root of 4 times 3. So that's 2 root 3. 2 root 3. But what they're using here in this second line is 3 root 2. So that's where the mistake is made here. And again, an explanation of that, and you will get the mark for that. The last question in this particular paper, again, was reasonably okay. Does require some thinking again about what density is. So this particular question is about density, mass, volume. So we will write that little triangle down here that we always do. So density, mass, volume, that's a useful triangle for us to have. And it's asking us to consider bounds. So when you're getting asked questions about considering bounds, you need to think about, if it's particularly this question talking about density, what we're being asked to find really is the maximum value of the density and the minimum value of the density. That's kind of what they're telling you to do. So finding out the density max and the density min. Now, in order to do that, it'd be quite useful for me to get my other dimensions, so my mass and my volume, in the units that are appropriate for that. So the mass, for example, is saying it's 1970 correct to the nearest 5. So we can work out our mass min, which is going to be 1967.5. So that's to the nearest 5 grams. And again, if you halve this to 2.5 and take it away and add it on, you'll get your 2 bounds. And my mass max, so the maximum value of the mass can take, is 1972.5. So the minimum value and maximum value. For each of these dimensions, we have to then construct a volume. So the volume minimum will be the minimum length, the minimum width, and the minimum height. So the minimum length will be 13.15. The minimum width will be 15.95. And the minimum height, 21.65. The volume max will be the opposite. All of those things as their highest values. So 13.25, 16.05, 21.75, the maximum values of those. And we're going to work out what that gets when you work out your minimum volume and your maximum volume. So you get your calculator and you tap those buttons in. Now when you do that, you're going to get some very long decimals. So I'll write what those are here. So 925.125. And then this one here is 4625.409375. So this is our minimum volume and our maximum volume. That must mean then that our density minimum will be so to get the smallest possible density, you're going to get your smallest possible mass divided by the maximum possible volume. So I'll just say that again. To get the minimum density, you need your smallest possible mass divided by the maximum possible volume. So your 1967.5 from up there divided by this one, the volume max. So this one, 4625.409375. The density maximum, the other way around, will be the maximum mass, so the 1972.5, and the minimum volume, so the other way around, 4540.925, 125. Now, when you work those out, you'll get some horrible decimals. I made a note of these earlier, so I'm just going to write these down. 425, 3677546, and this one is 1434, 3828506. Then we're going to flip back to the question because it asks you to give these things to a suitable degree of accuracy. Now, when the question says that, what you've got to do is look at your two answers and see where they agree, and you stop at the point where they don't agree, where they stop agreeing. So both of these numbers round to 0.4, so they're at least 0.4, but if you look another step up, so another decimal place up, both of these numbers round to 0.43. But you can't go any further. This one rounds to 425, this one rounds to 434, so they're different. So to get them the same, you have to stop at the point where they're both the same. So they do agree that 0.43 grams per centimetres cubed is the density to two decimal places. So both of these answers do agree on that. So that is why this is a suitable degree of accuracy, and hopefully then you've guaranteed your 5 marks. That is the end of June 2018 paper 2. Keep tuning back because I'm about to do June 2018 paper 3, and I'll carry on doing these and chucking these out in the next few days. And do keep an eye back on the channel because I'll be adding new content in the next few weeks. I wish you all the best for your exams in the summer. Good luck. Hope to see you soon. Bye-bye.